we're going to do is talk about what the computer is and what it can do, what it can't do, or whatever. We're going down to the wading in the baby pool and starting our work, working our way in. And the reason, I mean, I do this with my high school kids. It's like learning manual transmission and then going to the automatic. And when things go wrong, maybe you'll have a little idea of what's happening. And one of the things I tell the kids is, one problem is we think up here. The computer thinks way down here. And when we talk to the computer, we're trying to do things to the computer, we're telling it up here, and it gets confused because it doesn't understand. Because we're not telling it what it needs to hear. And so the problem is we're too smart for the computer. It's a dumb machine. It can only do one thing. It's just that it does things faster and more efficiently than we can. That's what makes it good, but it can't do anything we can't do ourselves because we have to be able to tell it to do it. So that's where we're starting out with. So why do we have computers?
Communicate.
Okay, communicate. I mean, why did they get invented? Why does anything get invented?
To make life easier.
Yes, looking for a way to make something easier. So I'm just gonna show you how it came about. Working through here. There it goes. We go way back to the abacus, back to the ancient Chinese. They were looking for a faster way to add. And they came up with the abacus. We still use it today. Bet we can go over to the Holy Spirit and find an abacus or two over there. Know that they're still used. From that, when we started getting interstate commerce, people were trading their goods and things, but a lot of times it was farmers. They go in and they get what they need, but they didn't have anything to trade yet because they didn't have their crops in and things like that, so that they had to write things on clay tablets to keep track of it. And then harvest time, they bring in, pay for it, they break the tablet, and that broke. They were paid up. But those things got a little cumbersome and so on, so eventually somebody came up with papyrus and paper. But then there was a problem. That stick that they used to engrave the clay with wouldn't work on the paper. So then somebody came up with pens and pencils and writing utensils and things like that. You work up into the 1600s, and Blaise Pascal made an adding machine. So we're talking 400 years ago, they had adding machines. Now, of course, it wasn't electric, it was mechanical, but they turned these dials, and it even had it to where these numbers appeared up here. They clicked the thing over and so on. It never caught on. Because at that time, the biggest thing with using numbers were accountants, bookkeepers. And most places had, if they were a big business, they had 2 or 3 accountants, usually a 3, because they'd add up all these long columns of numbers. Well, if they all 3 agreed, they knew they had it. So that was their checks and balances with that. Well, if they got this machine, guess what? A couple of those accountants would lose their jobs. So 400 years ago, they were already worried about job security to technology. So it didn't catch on. In the 1700s, Jacquard came up with, they had the loom for weaving. But these patterns that were in the cloth and so on, it got to be tedious that, that they were always doing that. Where mistakes were made and so on. So he figured out a way that by punching holes in these things, this paper, this hard paper, and having that run through the machine, it knew what patterns were for the cloth, for weaving it. So putting those holes in there, that was programming. That was programming that machine. Mechanical programming, but programming nonetheless, back 300 years ago already. That was done. Now, that evolved, and eventually we get up to Herman Hollerith. And in the 1800s, so we were doing the census every 10 years. And what was happening, if you think about Iowa, 100 years ago, 120 years ago, a lot of towns were popping up. Well, they were taking the census like in 1870. It took them almost 9 years or more before they had the information ready. Now, they used the census figures for representation, for money, and all that things, not just counting the people, but how to they use that numbers for a lot of things. Well, if it wasn't being done, and it took them 9 years to get that information, there were a lot of new towns out there that, as far as the census was going, they didn't even exist yet. So it was taking too long. So Hollerith, they asked him to come up with a way to do this. He used the idea from Jacquard's moon and came up with a punch a card. And I have one that's similar. It looks like this. I mean, this is the size of what the punch a card was. Now, some of you might remember when your bills and stuff in the mail even came with the little holes punched in. You wouldn't even remember the card. When I started taking computers in college, this is how we put everything in. We had to type everything in a card, and it read into the machine. Well, they had a pattern that there were 3 lines here, X, a Y, and a Z. And if you didn't use any of these, you had 9 numbers down here. So if you had that whole punch, that was what number it was, 0 through 9. But then if you put it with an X or a Y or a Z, then you use the 2 punches, then you could use the letters A through Z. So there was a pattern to it. So if you look here on the, you kind of barely see it, but like here's an I, so it's got the X punch and a, on the right column here. And so it's got the 6 and what's the O. But they've got the different combinations. You could actually read those cards. But eventually they got it so they also typed across the top what that was. The machine read the holes rather than that. Well, by coming up with that, then they had a machine they made a machine that could read this information and tabulate it. It's a tabulating machine. And this was in the 1880s, or 1870s, no, 1880s, because by the time for the 1890 census, they were able to cut it down to 2.5 years because of this. So that was another big thing that we took from that. Interesting thing of this, they had to make millions of these real fast when they started doing this. The only place that was set up to do this was the Bureau of Engraving. So this was the size of a dollar bill. If you put a dollar bill up to it, a dollar bill is smaller than this because money shrunk. In 1928, they changed the size of the dollar bill, but they didn't change the size of this. Why not? And this was also storage. This is the way they kept information until the 1980s and 1980s before they really started using discs and stuff, so everything was kept in a card. Well, if they changed the size of the card, they'd have to change the size of the machine, and if they changed the size of the machine, the old cards were obsolete. obsolete. They couldn't use it, so it stayed the same. So that was the size of the card. Then, and then they made these machines. They called them tabulating machines, and they had a company that made accounting machines and tabulating machines. They eventually merged with another company that did some of that, and they called themselves International Business Machines, IBM. So IBM's been around a lot longer than computers. Then we got to the first, whoops, I didn't change the name down there. Then we got to the first computer. The first electronic computer was made in 1939 by Professor John Vincent and Tanisov at the University of, at Iowa State University. It's called Iowa State College then. He made it at the university. He was a physics professor, and he used the idea of the punch card and the loom and a number of other things that had been developed, and he made this electronic computer in order to help his physics students solve things a lot faster. The calculating machines that they had at that time, mechanical, just couldn't do what they did. So he came up with this. And actually, if you read a lot of history books, it will not credit him, but credit somebody out. The first one was the Sperry Univac computer out at Harvard. But he had two, it was Barry and I can't remember the name of the other guy, because it was called the ABC computer. And they were grad assistants. And they went out east to get their more education and stuff. And they used what they learned here, and they made this computer, which was actually used during World War II. And it was used for defense purposes and things like that. Well, and Tanisov said, hey, I made the computer. Because he also got called into some stuff with the war, and the university, or Iowa State, didn't apply for the patent. And so it got into a big mess. And of course, since the other one was involved in the war, all spare and love in the war, so they were at war, so we don't touch this right now. In 1973, they went through the courts, and they said he indeed did have the first computer. It wasn't decided and all that. And that's a picture of him. I read that there's all kinds of, he's of Bulgarian descent. There's all this stuff over in Bulgaria now that has his name on it. Computer. So I just kind of get us an idea of where things have come from and where we're at now. Now, over the time, if we had taken cars have been around for about 120 years. Computers have been around for basically 60 years, 60, 70 years. So almost twice as long as, or the cars have been around almost twice as long as the computers. Well, if cars had changed the same way computers have changed over that time, we'd all be driving Rolls Royces. They would cost us about $2. We could park it and 5 others on the head of a pin, and it'd get about 60 to 70,000 miles to the gallon. Or you could probably put a couple of dollars worth in, and when it ran out, get a new car. So what it did. Those first computers were huge. They filled rooms. And that's because the first computers used vacuum tubes. Lydia wouldn't have any clue. Some of us may remember seeing vacuum tubes in the back of TVs and radios and things like that. But you got rid of them long before you were around. But this is a vacuum tube. Now in the computer, it represents a 1 or a 0. That's it. That's all the computer can do, is recognize whether something's a 1 or a 0. If this was on, it represented a 1. If it was off, it represented a 0. That is called a bit. A 1 or 0. And it comes from 1 or 0 is binary, and so binary digit, they shortened that to bit. That's what it represents. Now, you can't do much with a 1 or a 0. But if you put it together with more of them, you can make more numbers. So if you had 2 of them, if we had 2 of those, we could use a 0 and a 0, a 0 and a 1, a 1 and a 0, or a 1 and a 1. So we can make 4 different code numbers. Not enough. Put a third one on there, it doubles to 8. Put a fourth one, you got 16. Fifth one, you got 32. Sixth one, you're up to 64. Now, we have 26 letters in our alphabet, but to the computer, we have 52. Because we have uppercase and we have lowercase, and they have to be different. And we have 10 numbers, and then we have, so that's 62, but we have periods, commas, question marks, all those things. So that's not enough either. So you go to 7, and you're up to 128. That's an odd number, so they went to 8, which is 256. So you put 8 of these bits together. So that's a bit. You put these all together, and 8 of them make a byte. And actually, they also, the computers now use half bytes. Those are called nibbles. All right, so a byte is 1 character of information. It takes 8 bytes to make a character. So in the old computers, we used these vacuum tubes. You needed 8 of these to represent 1 character of information. Now, if the computer on your desk, that you're using in school, they've changed it now. We have to, what are they at, 512?
Oh, they're more than that, I
Okay,
think.
gig.
I think they're a gig.
Okay, we'll say again. Now, we have kilobytes. And K, the metric system is 1,000. But in computers, it's 1,024 because it's 2 to the 10th power. It's 1,024. We can call it 1,000 to round it off. Okay, and that means 1,000 bytes or 1,000 character of information. The first computer we got at Kemper, its memory was 4 kilobytes. So it held 4,000 characters of information. We thought we had something. Okay? Then they went to megabytes. We can say that's 1,000,000. Now we're talking gigabytes. And that's billions. Actually, now you can buy hard drives out there that are terabytes, which is a trillion. It's just going like that. Now, the computer on your desk has memory. Now, there's memory and there is storage. Memory is what's up here. Storage is when you write things out on paper to keep and look back at. Storage is the hard drive. Storage is a floppy. Storage is a CD. Storage is
Flash drive?
flash drive. Thank you. It's not stored up here real well all the time. the memory of the computer is like your desktop. That when you're working, everything has to be on your desk. So if you're running a program, that program has to be in the memory of the computer, which we call RAM. And all of the information that you're working with needs to be there. RAM is volatile, which means when you shut the computer off, it clears the memory. It's kind of like you go to sleep and your mind goes blank. Except for when we wake up, there's stuff still there, hopefully, but there, it's gone. Okay, so when I talk about memory, I'm talking about this part of the computer, not the storage stuff, because you can add storage. All right, so if the computer on your desk is 1 gigabyte, 1 billion, bytes, and it takes 6 or 8 bits to make a byte, then that means it's 8 billion bytes or bits. And with the old computers, that means you would have had to have had 8 billion of these. Can you imagine 8 billion vacuum tubes? That's why those were so huge. But they weren't that huge, because it was just physically impossible. Plus, these give off, they're like a light bulb, they give off heat. It would have been more than a sauna. And they also burn out. Not as easily as a light bulb, but they do burn out. So they had to come up with ways to check to make sure that when one burnt out, that the computer figured it out. Won't go into that one, but there is ways for doing that. Okay, so what has happened then when we talk about that car is because the computer used the vacuum tubes, it was so huge. Well, in the 1950s, we had Sputnik go up, and we entered the space age. And what was being pushed then? Math and science. And one of the things to come out of there was this, a transistor. I remember as a kid, we got our pocket radios. You had to tell someone, mine's 9 transistors. You measured it by how many transistors it is. Well, the transistor replaced the vacuum tube. Big improvement. You could get a lot more of these, and they didn't give off hardly any heat. And they didn't burn out very easily. So it took care of 3 major problems right there. So then the computers got to be very much more handleable as far as being, they could have things in a room like this with no problem. Much more accurate and manageable. Then it wasn't long and we got to the next thing, which was we got the integrated circuit. And this is 256 megabytes. So this has 256 times 8, which would be what, 2048? It has over 2 million. This would replace 2 million of these. So we really got small. This would replace 2 or 3 rooms of these, to get to that. So the next major improvement. So that's why instead of driving, we could park all those Rolls Royces on a head of pin. Also, this took a lot of electricity. That's why it was giving off so much heat. This takes barely anything. This is a little static electricity. So the power that's used You know, if we went back to if you made the old computer, plus it had all the wires in there too. If you made an old computer to match what our computers do now, it would take as much electricity as it takes to run the New York subway system. I don't think we want to pay that electric bill, you know, to do that, especially when you multiply it by the 400 computers we have in this building, in these buildings. It would be awful. So, the changes in the size there. Any question on any of that? All right. Now, as far as what the computer can do, the computer has 4 main parts to it, or even to a computer system. We have to have some form of input, getting the information in. We have a process that happens, and then we have output. And we could have an optional 4th thing, storage. Sometimes you want to be able to keep what it does. Now, this is called data processing. Because if you take data, and data processing sometimes gets confused to be computers. Computers is a part of data processing, but data processing has been around a lot longer than computers. Data processing is taking a bunch of raw data that we can't make any decisions from, doing something with it. Like if we had a bunch of bills and we had our income checks for the month, which is what, 1 for us, compared to all the bills. Okay, you can't just look and see, well, I got a stack of bills and 1 check. Did you come out ahead or what? You can't tell until you add these up and find the difference. That's processing the data. Whether you do it in your head, you use paper and pencil, you use a calculator, you use a computer, you're processing. The output is that number that tells us whether we're came out ahead, we can make a decision from. We subtracted the bills from the income and we got a positive number, we came out ahead. If it comes out to 0, we broke even. If it came out negative, not a good month. No. So we can make a decision from that. And then if we want to store it, then we're going to keep it. Now, input is very important, because what goes into the computer, or what comes out of the computer, is only as good as what goes in. They have the statement, garbage in, garbage out. You put garbage in, you're not going to get anything good out of it. Happens a lot. So getting that input in correctly is an important step. And what they try to do, they try to eliminate the human as much as possible, because that's where the mistake will come from, you know, most times. So that's why you have the stores that have scanners, because they don't have to push the buttons, they just have to run it over the scanner. Now, there's still a human error that can be made there, that the human entered the information into the computer wrong, which happened at one of the airlines this last week.
Oh, yeah. They give like basically free tickets.
Yeah, it's coming up 000 for the price of the tickets. And they did say they'd honor it, but that one went viral on the internet. Somebody discovered that one, you know, free tickets. But again, it was a mistake. And so the output was not the way it was. Now, so we have, you know, it can be keyboards, a mouse, voice recognition, the scanners. There's a lot of ways of getting the input in. The output has to be something that we can make sense of. Now, it all depends on what it is. Now, the output could be just on the screen, it could be printing out on paper, it could be voice. There's a lot of ways for that too. And then storage is putting it on somewhere that's going to keep it for us. Now, storage has also changed a lot. Originally, this was storage. Then when the first computers came out, first personal computers came out, they had cassette tapes, even for the programs. It was very slow because you had to go by everything to get to what you needed sometimes. Then they went to the discs. And this was the first disc. They're huge. Not too many people have seen these because they weren't around very long because they were able to make a big step. They had these, but by the time that the personal computers really caught on, they had gotten to the next stage because that's this one. So most people recognize this. This is actually a mini disc. But they were always like, well, why is it a mini disc? You know, but that's because this one's not, the original. And then it went to the micro disc. And for a long time, we had people that were calling this the hard disk, and it's not. It just happens to be the outside, but the actual disk itself on the inside is just like this one. But what's interesting is, of these three, this one holds the most, this one holds the least, because as they made it bigger, it also became more dense that they could put things in there. So then, eventually we got to using the CDs and DVDs and that. And this is a hard drive. It's a smaller one. But all the hard drive is, it's also got a disk on the inside there, but it's made of a little harder material. And then there's a little arm on here, and the arm moves back and forth to read off of there, just like on a CD player or anything like that. Only the stuff is recorded on here magnetically, and it's all ones and zeros. That's why it's digital. Digital, when anything they say is digital, that means it's been recorded with ones and zeros, and it then has to convert it back and forth. So this is mechanical. So this is actually the slowest part of your computer. When you have things on the hard drive or any drive, it actually has to move to read it. And so when there's a mechanical process, it's slower. But when you read off of your flash drive, it's all just electronic. So that reads off of there much faster than off of these. So that's why they tried to work toward those. I'll pass that around. You can look on the inside of it because you don't get to see the inside too often of the hard drive. All right. Now, which, by the way, I think we're doing this in sections here. We'll work on this, and then we'll get into, work our way a little deeper each time. I don't want to overload you at one time here. All right. The process for us, that's the computer. And we're going to look just briefly at what actually goes on inside that computer. And we said that it only knows ones and zeros. And it can actually only do one thing. And that's, it can decide, or one type of decision. It can compare two things, and it can decide yes or no whether they are equal or one's bigger than the other, or they're not the same. That's it. All of our programs and stuff that we make are putting logical things of using that together, and we'll get into that. But inside the brain of the computer, which I don't have a CPU here. I should have brought one, but I can do that. It basically is about the size. It's on the motherboard, and it looks almost like one of these chips, only it's a lot bigger. It's usually about that big. and it just plugs in, and that's the brain. But in the computer, it's divided into two parts. The CPU. The CPU stands for Central Processing Unit. CPU, Central Processing Unit. And it has the arithmetic logic unit. And it also has primary storage. And then it has a control unit. So what happens? You have your program, whether it's Word or any program you're running. The computer is going to look at the very first statement, the very first command, and it has to decide what it needs to do. And then the control unit is going to tell what has to do what. Now, in the memory of the computer, your data is going to be stored in there. So maybe it's going to tell it that it's going to take the, that tax is equal to sales times 0.07. So somewhere in the memory, it has a little cubby hole in there, like a mailbox, and it has named it, it just wrote a name on it and called it sales, whatever we told it it was. It doesn't know what sales means. It's just given it a name. And it's going to put in there what we said sales was, whether it read it from, you know, if it was typed in or however it got in there. And let's say it was 200. And then we've got another place called tax. It doesn't have anything in it yet. So it's going to, the control unit's going to look at this statement and say, okay, we need the value of sales and we need to send it to the arithmetic logic unit. So it sends that 200 to the arithmetic logic unit. And then it tells it, multiply it by 0.07. So the two things the arithmetic logic unit can do arithmetic. It can add, it can subtract, it can multiply, and it can divide. That's it. Technically, multiplication and division are repetitions of addition and subtraction. They're functions of that, but these would be the basic operations. The logic unit compares. I can say if, and then give it a comparison. And it can compare whether two things are equal, one's less than the other, one's greater than the other, one's less than or equal, one's greater than or equal, or they're not equal. And from that, it comes up with an answer of true or false, yes or no. And then the program has to say what happens if it's yes, what happens if it's no. All right, so it's going to take the sales times 0.07, and then the control unit is going to say, okay, we're going to put that in tax. So it sends it back to the storage, or to the memory, and puts $14 in there. And then that's going to stay there for, and then the computer might use it, that number somewhere else in place. That's what it would do for one one statement. Now a program can be hundreds and hundreds and hundreds of statements. The more complex the program, the more it's going to have. And it's just going to be repeating. But it's a whole bunch of statements saying how it works. And we'll look at doing what a program does later as far as actually looking at one with that. Now, the other thing with the primary storage then, this is called RAM. RAM means random access memory. By random, it means it can go anywhere within that memory to pick the information out. And by access, it can also means it can read and write. It can read from the memory and it can write to the memory. It goes both ways. And I said before, it's volatile, meaning that if you shut the computer off, it wipes it clean. But that's where everything's going to be stored. And this, so when they tell you that the computer has a gig of RAM, they're saying that that main memory of its computer will hold 1 million bytes of information at any one time. Now, when you're running you got Windows up. Windows is actually a menu program. It's just organizing things for you, and it lets it multitask, do more than one thing. You got a bunch of programs open. Every one of those programs that's open, plus Windows itself, is taking up memory. So it's cluttering up your desk. At some point, if you're working on your desk and it is completely covered, you can still work, but can you work as fast, as efficiently? Because you're constantly looking for things, or you got to move things here, move this out of the way, and so on. That's exactly what's going on in that memory of the computer. When you get to the point that you've got it almost filled, it runs slow because it's got to be moving stuff around. Even though it's working at the speed of light, it still takes it a while because it's got to do millions of things to move things back and forth to get it out of place, because it doesn't move a whole book at a time. It moves them a character at a time. Technically, it moves them a bit at a time, but it just does it so fast you wouldn't realize it. Okay? So that's why you don't want to have too much open. Or if things are getting slowed down, close something that you don't need. The other thing that happens in the hard drive and stuff is that things get all, same thing, it gets all cluttered. There's ways of going in and reorganizing so that it's a little less than that. But that's RAM. The other kind of memory in the computer is called ROM. And that's read-only memory. And that was put there when the computer was built. But it's on a chip, so when they made the chip actually and that went into the computer. That is what the computer needs in order to even when you turn it on, so it even knows what to do. When we're born, our minds are not blank. There's stuff already in there. Because we have to know certain things. We have to know how to breathe, we have to know how to take nourishment, all those different things. Those are already going. There are animals that have a lot of things already built in. Those instincts, they're already there. There are some animals that are born and they're on their own. So those things are there. The computer's the same thing. When you turn it on, it has to know where to look to get the information to continue. So that's what ROM is. And it's read-only in the fact that you can't write to it. You don't change that. It just reads that. And it's non-volatile. You turn the computer off, it's still there when you come on. So it's more like our brains that we go to sleep, wake up, it's there. Sometimes it's a little foggy and you gotta get moving, but it's all there, hopefully. Okay, so that's the way that runs through there. When it's done with the process, then it's going to put it somewhere. I'm going to bring up a word today, and I'll bring it up several times, and it's called default. The computer is dumb. It doesn't know what to do. We have to tell it everything. So a lot of your programs that you run have all these defaults set into them so that we don't have to sit there every time we start up and tell the computer all the things again, that they're set that way. So like your printer, it's got a default that if you don't tell it otherwise, that's where it's going to go, because it needs to know. If you don't tell it something, what is it supposed to do? When you start up Word, it's been set with the default as to which font and what size. And you can change that. But there's factory settings, so again, that people can just turn on, load their program and start using it without having to set all those things up. Used to be we had to do that. And actually, in the second class of this, I'm going to show you how DOS works and show you some of the stuff that happens before Windows. And I think that will also help you so that you can see what it's actually doing. I kind of compare it, if you learn to drive with an automatic only, you don't always know what is that transmission actually doing. That sometimes, you get into the mountains, you sometimes have to help that automatic transmission. You may need to gear down or something. But if you learn to drive with the manual, you understand what's happening. Even though you're using the automatic, there may be times that you need to override the automatic and you can see what's happening. And that's the same thing here, that you might have the understanding of how are things going. So it's like when you print and you just tell it for it to save. When you tell it to save something, if you just use save, it's going to save it back to the same place you pulled it up from. But if it's something new, it doesn't know where you want it. And if you simply save it, it has already been told the default. And I think in most cases it's to My Documents. I think with the word in that now. But sometimes it may save it to another place. And unless you watch where it goes, you may not know. So the first time you save something and you use save as, you want to look to see where is it going, or you tell it where to go. Otherwise, it's going to save it to the default. And then it's hard to find. It's just like somebody opening up the drawer and throwing it in the file, and then you go to file it and you got to sit there and search as to which one you put it in. So that's also what's happening with the saving and printing and that type of thing. So the computers don't. And that's what we have to kind of remember. We have to tell all those things. Okay, I kind of got to the bottom of my list there. Questions that you have that maybe you thought of as we were talking about things. Again, this is probably stuff that, like the kids would say, when would we ever use this? They're about some of this, but it's the idea that understanding where the things came from and how it's working, I think will help in understanding why those programs are doing what they're doing. Because I know it's frustrating when all of a sudden it's not working right. But sometimes it's not a case that it's not working right, it's just not working the way you're expecting it to work. But it's working the way it's been told to work, and you're not on the same wavelength, as to what's happening. And unfortunately, the computer can't figure out what you meant. We have to figure out what the computer did or what the computer meant. So hopefully we can figure that out.